Given the rate at which new technologies are pushed into the world today, it's challenging to understand which will succeed. The goal of any technology is just to do useful things, which seems simple enough. Engineers would not spend time building something they thought would be useless. However, usefulness is not solely determined by the technology's capabilities. The person working with that technology has the final say on usefulness. Their ability to understand the system and control its behaviors are key elements of usefulness, as pointed out in Donald Norman's book, The Design of Everyday Things, where he leverages Gibson's idea of affordances. For more complex and longer-term interaction, not only must the affordances of the technology be effective, but the technology's behaviors themselves must fit within the effective human work practice. The DoD is an example of an entity that needs fast technology development to maintain its edge. Unfortunately, many of the advanced robotics and AI concepts fail once they are put in the hands of the warfighter. The DoD needs a cost-effective way to rapidly develop new concepts and vet them with their users, the warfighters, so the ideas can fail fast early, allowing iteration toward the best viable solutions. IHMC has developed a suite of tools called the VR Workbench, aimed at leveraging the power of simulation and virtual reality to de-risk new technology concepts in a fast and iterative way. The key enabler is providing a framework to allow warfighter-centric design and evaluation of new concepts. The warfighter must experience the new technology within their work processes to fully understand the technology and its operations. This interaction of people and technology in an environment and within a mission context will help identify the critical issues currently unseen in envisioned technology solutions. The VR Workbench has advantages during design, evaluation, and specification. During design, it uses a minimum viable product to minimize time and cost. As an example, consider trying to design a fast food restaurant. You could build a restaurant and see how it goes, or you could use a low-fidelity simulation, like chalk on a tennis court, to try out some ideas. The idea is you need people doing their jobs to know if it works. Your first attempt will reveal some issues, and you can refine it, which may cause other issues, but eventually you'll find a good solution. VR provides a similar environment in which fidelity can start low and be incrementally increased to reduce risk, manage complexity, and manage the cost investment. It provides a flexible environment for quick prototyping. Most importantly, it's an easy way to enable engaging the warfighter early in the design process, which is important to good design. Warfighter engagement is also critical during evaluation. Early warfighter integration allows systems to fail fast early. To be an effective evaluation, it must simulate both the technology product and the process by which it is used. We use VR to enable the warfighter to interact with the technology in an environment and within a mission context. This experience will help them better understand the technology and properly evaluate its impact on operations. It allows operators to try out concepts under situational contexts appropriate for proper evaluation. It also enables head-to-head comparison of different solutions and in different circumstances. Finally, the VR Workbench approach can be used to help derive clear specifications for vendors proposing solutions. Too often today, technology vendors push their solutions onto warfighters without understanding or designing for the warfighter needs. Our approach provides a means for the DoD to work through concepts and provide meaningful and detailed specifications without requiring the time and effort necessary to fully develop a technology. This puts the DoD in a stronger position with vendors. All of this is what it means to provide a framework to enable warfighter-centric design and evaluation of new concepts, and this is what IHMC's VR Workbench provides. While we are demonstrating the utility of the VR Workbench in the DoD domain, the basic principles of human-centered design are applicable to development of technology for any domain where people want to understand the potential usefulness of a new concept.